Hey everybody, today we're going to be making Minesweeper in C. Everybody knows Minesweeper, the digging for little mines game. Very fun. It's actually my favorite game. Okay, so yeah, today we're going to be programming this in C, so let's just go ahead and get started. So far I have a library directory with SDL3 and a makefile. This is the same makefile basically as was in my last video when I made Snake, except I have changed all the source object and executable to Minesweeper from Snake, and then instead of using SDL2, we're going to use SDL3 today. So, same idea. I'm just going to get started. I'm going to make Minesweeper.c. Open that up. First, I'm going to include all of the necessary header files that I'm using. Okay, we have all those. Now we can make our main function. And, you know, I always like to start off with good old friendly hello world. Okay, let's make and run. Hello world. So now that we have our hello world working, now let's do a little hello window. So as is routine in SDL, we're going to create the window and the renderer. Now we'll create a little loop with a running true boolean while running SDL render clear. And SDL render present. So we want to clear the frame buffer on each frame and then update the screen. Alright, now after we run out of that loop, we'll need to clean up our SDL variables. SDL destroy render destroy the window and quit out of SDL. Return 0. Let's try pulling for when we want to quit. So to do this, we're going to do SDL event E while we are polling for an event. So it just gets the current action taken. If e.type, so the event type is SDL event quit, running equals false. This is our handling player input. Let's try again. Okay, here's our little window. Perfect. Now it's working. Right now I just hard coded to 100 by 100. It's pretty small, but we just wanted to see it. Now, when you're playing Minesweeper, there's 3 difficulties. So let's launch the Google version again. So easy, medium, and hard. Easy has 10 flags, so 10 bombs on the map, and it's 10 by 8. Medium has 40 flags, 40 bombs, and it is 18 by 14. And then hard has 99 flags, 99 bombs, and it's 24 by 20. So I want to do the same thing in my Minesweeper. I want to have 3 different modes with those same sizes and same number of bombs. How I'm going to do this is create a game mode struct to represent those fields that change depending on which difficulty you're on. So let's define a struct called game mode. These game modes obviously need the bomb count. It needs the width of the board, the height of the board, and then for rendering purposes, we're going to use a tile size. Okay, and I just went through all of them. There's 3. We're gonna make them right here. Okay. Now I want the ability to choose what game mode based on the argument that you pass when you run the executable. So to do this, we need to change the signature of our main function. You do int argc, comma, char star argv. Okay? So it's the count of the arguments and then the actual strings that are passed. So the first index is the executable name, and there's no way around that. You need to have the executable name, so there's always at least size 1. So let's select the game mode. I want it to default to easy if you don't pass 1, so I'm just going to start off with that. The current mode is easy, but if we do pass a difficulty, it's going to be size of 2, and we're going to do if string compare of the first index, so index 1, I guess the second index, but index 1 is equal to easy. Let's copy this, else if it's medium, current mode is medium, and then finally if it's hard, we want it hard. Okay, great. So now let's see if we can use these arguments. So we'll remake it. Okay, that's fine. It's not used currently. So thanks for the warning. Let's put that in here. Current mode dot width and current mode dot height times, of course, the tile size. Let's make again. No warnings. We'll run it. So no argument, defaults to easy. So that's size easy. Let's make sure medium is larger. That is. And hard, even larger. Okay, so that's working. Awesome, that's fun. So we have different game modes. With the different game modes, we obviously now need to make the initial form of the game, the structure of how the game's going to work. So let's go, after we create our window and renderer, let's create an array of bombs. And so we're just going to represent that as an integer array. So let's create the array of bombs. So that's int bombs, our current mode's bomb count size. Okay. So now let's go up here and create a function to randomly generate these bombs. It's going to be a void function because we're going to pass in the bomb array by a pointer and update it that way. So the range is going to be the number of tiles that there are. So width times height. And the reason why we need that is because we're going to, instead of just randomly generating values in that range, we're actually going to shuffle those numbers around because we don't want to, we don't want duplicates. We want 10 distinct, unique bomb locations. And if we just keep generating numbers, there's potential for it to just take too long to generate. So shuffling is the best way because every single number is going to be used once and randomly dispersed. So let's create an array of those numbers. This represents kind of like the deck of cards. So we're just initially looping through and assigning each index of the array its own value. So 0 is 0, 1 is 1, 2 is 2, and so on. Now we want to loop through the first number of bombs that there are. And we want to randomly find another index. So we're going to do int j is I plus random mod range minus I. Okay. And then we're going to get a temporary variable to store it and then just reassign it. So what this is doing is just swapping the location of one number with another. And then we put that number that was just taken and shuffled around into the bombs index. So now we have bomb count number. So let's call that n. We have n randomly shuffled locations within the range, which is width and height. Now we can pass this in our function with current mode dot width times height, our bomb count, and the bombs array itself. So with those bombs now, we need to determine what the value of each tile in relatance to those bombs are. Because if it's right next to it, if there's only one bomb touching it, it will be 1. If there's 2 bombs touching the tile, it'll be 2, and so on and so forth. If there's no bombs touching a tile, it'll obviously be 0. We need a way first to represent a tile, and then we can create the grid of them and then calculate these values. So to represent a tile, we're going to create another struct for the tile. So let's define another struct. As I mentioned, it has the value 0 to 8. 0 if it's not touching any bombs, and 8 if it's completely surrounded by bombs, and this can just be an integer. And we're going to need an enum for like what the state of the tile is. So a tile is either hidden, meaning we haven't interacted with it, it's revealed, meaning we left clicked on it and we're seeing the number, or it's flagged. So we think it's a bomb, so we put a flag there so we don't click on it by accident. So let's create an enum for this state. With those 3 that I just talked about: hidden, revealed, and flagged. After creating the array of bombs, we can create the grid of tiles. So this will be a tile called grid of current mode, height, and current mode tile width. So it's a 2D array. Then we need a function to calculate what its values are. So let's call it calculate mine proximity. It's going to take the width, the height, the grid, the bombs, and the bomb count. Oops, we put that inside the game mode, current mode dot bomb count. Now let's write this function. So once again, this function is void because we're going to pass in the grid by a pointer so that it just gets referenced that way and not actually returns it. I'm just going to remind myself that the grid is y, x, like that. And we're going to loop through each of the bombs and then increment the value for every tile around it. So from 0 to the number of bombs, increment through. So now we stored the bomb array as a single integer that represents a location on a 2D grid. So we need to somehow map that linear location to a 2-dimensional location. So to do that, I'm going to create one more struct for a 2D coordinate with x and y. And now with that, I'm going to create a helper function which returns a coordinate called map linear to 2D. It takes an integer with the linear position, which is what is stored in the bomb array, and then also the width of the board, of the grid. So this is pretty simple math to understand. So take our coordinate. The y value is the linear position divided by the width. So the height of it, every width is another y. And then the x is the modulo of the linear position and width. So the remainder of the height. Now we can use this function in our loop to get the coordinate. For the bomb at that indice. So in our grid, we're going to mark bombs as a negative value. So mark the bomb coordinate as a mine. Grid yx is -1. Then we're going to use a little fancy trick. Let me assign that to the value, of course. We're going to use a little fancy trick to iterate through each tile surrounding the current tile. So it goes down 1, left 1, up 1, right 1, and then obviously both up and left, up and right, and so on and so forth. So we can do a dy that ranges from -1 to 0 to 1. And then same thing for the x, to go left and right. So when both of these values are 0, that's the current location where the mine is, so we just continue instantly, skip it. Then we can calculate the new x position by x plus dx and the new y location as y plus dy. We want to ensure that we don't go outside of the array's boundaries. So if nx is less than 0, obviously that's not a valid address in the array. Or if it's greater than the width and height, we also want to continue here and skip them. Furthermore, if the current grid is a bomb, so one bomb is touching another bomb on an adjacent tile, we want to just leave it as a mine. So continue it. Don't increment it, because then it won't be represented as a bomb anymore. finally we can increment. After iterating through each of the neighbors of each bomb, we have the core structure of the Minesweeper game complete. So now it's time for us to render this to the screen and show what we're doing. So in between clearing the frame buffer and updating the screen, let's create a function to actually draw the screen. I'm just going to call this function render for now. It's going to be a void function because it does not return anything. In Minesweeper, each number adjacency has a different color. So when it's 1, it's blue. When it's 2, it's green. 3 is red, and so on and so forth. So I'm going to create an array of SDL colors for 0 through 9. Sorry, 0 through 8, meaning there's 9 of them. So we're going to loop through each tile's width and height. And to do that, we need to pass in these as arguments, as well as the renderer, who's going to be doing the drawing. As well as our tile grid. And the size of the tiles. So that should be good on the arguments. Now we just set the render draw color of our render to the color RGB values. And of course the alpha value as well. The color is going to be determined by the index of the grid's position. So the value of that tile at x, or x comma y, relates to that array of colors. We need to render the rectangle. In the SDL3, they now use floats, so it's an frect. Kind of a silly name, but you gotta do what you gotta do. X times size, y times size, width and height are both size. And then fill the rectangle. Now in our game loop, we can pass in the arguments. Let's give it a shot and see how it works. Okay, to help me troubleshoot this, I'm gonna move our generate bomb locations and our calculate mine proximity into a single function to initialize these. So I'm gonna put this over here. So we're gonna create the array of bombs and the grid of tiles. And we're gonna create a new function for initialize Minesweeper, taking width, height, bomb count, our tile grid of for sure our height and width, and the bombs array. Randomize our bomb locations by calling our generate bomb locations function. Our range is width times height. Bomb count. And our bombs. Additionally, I'm going to print out the locations of the bombs to the console with their linear position, so it won't give away really, unless you can do math really well in your head and visualize which cell is which. So first at each bomb location, and then we need a new line afterwards. It's the bomb location. Now construct the board based off the bomb locations by calling our calculate mine proximity. And I think we actually need to initialize them all first, so we're going to use memset on grid for the size of tile times our width and height. Okay. Then down here, we can call our initialize Minesweeper function with the mode variables. Third time's a charm. Let's see. Oh, we have an error. Oh, void. This is a void function. All right. Compiled. Let's see if it works. Okay, awesome. Let me specify what color the bomb is real quick. Really quickly in here. So when it's less than 0, we're going to do this. But we're just going to pass in, we're going to make it black. 0, 0, 0, else. Do these. Oh. Alpha's 255. Okay, now it's much more clear where those bombs are. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 bombs on easy. So that's all working correctly. I like the look of this, but it's not very easy to understand what I'm looking at. It'd be very difficult to play this version. It's much more readable and playable if we can have a number to represent it and not purely the color. We actually need to make 2 separate render passes. The first is going to be the tile color, and the second is going to be the number. So this is going to turn into our second pass. And then we need a first pass. So in Google's Minesweeper, the revealed tiles have like a sand color and then like a grayish tan color. And so we can use the same colors for our game. We have our light tan and our dark tan color. The way I get these, if you're on MacBook, there's a tool called Color Picker or Color Meter, and you can zoom in and get these RGB values. So this is super helpful when I'm programming to get colors just from things on screen if I want to recreate them. So for our first pass, again, we need to loop through the X and Y for each tile. We're going to use modulo for even or odd. To determine if it's light or dark. Okay, so now it'll alternate between light tan and dark tan, and we need to change this from rendering the color to rendering numbers. First, we need to set the render draw color to black. And then set the scale. Because typically this debug text is set to 8 pixels by 8 pixels, and that's just way too small. We need to make it fit our specific tile size. So we're going to render the scale up to 4 times, 8 times 4. So instead of specifically rendering the bombs a certain way, let's render everything that's greater than 0. So we need a buffer for the character we're going to render. And then the null terminator character. With that buffer, we can call SDL render debug text with our renderer. We need to multiply our x times size and then divide that by 4 because it's being scaled up. We need to scale it back down for the position itself. Same with the y. Pass in our character buffer, and that should be good. Oh, real quick, we need to get the color that we want. Let's see if this works. It compiled. It looks like we forgot to rescale it back to the original scale. So let's just add that real quick. So after the second pass, let's take this down to 1 times. Awesome. Let's see what it looks like on medium. Nice, we've got some 4s, some 6s. Let's see what it looks like on hard. Super cool. So the core of our game is working. The only thing that's left to do is the actual gameplay itself. As fun as it was to have X-ray vision, obviously the game needs to start off with hiding the tiles. So it's time to start using our state enum that we used and hiding them with the green grass. So Google uses a dark green and a light green color. We're going to do the same thing. In our loop for our first pass, we want to check if the state of the tile is hidden or if it's flagged, basically not revealed. If so, instead of being light tan and dark tan, it's going to be light green or dark green. these over. Okay, so the numbers are still peeking out through us. In addition to checking if it's greater than 0, we also want to make sure that the state is revealed. Just like that. Give it a quick try. Perfect, everything is hidden. Now we need to actually be able to click it and reveal them. So in our game loop, when we pull for the SDL events, if it's not quit, we want to check. So if e.type is SDL event mouse button down. Do I have that? Yep, okay. There we go. Running is going to be the output of our input. We're going to pass in the button that we use, our tile size, tile width, tile height, and our grid. So this is going to return whether running it continues or ends. So it's true when you don't game over or false when you do game over. So we want to also check if the running flag has been set to false. If it's not running anymore, I want to print out game over. You lose. So let's create this input function now that returns Boolean. So it takes in the SDL mouse button event and then size, width, height, and our grid. First off, we want to get the tile that was clicked. So we can do that by taking the button's X divided by the size, and the Y the same way. The button's Y divided by the size. Just for visibility, I'm going to print this out. Now we need to check if it's a left click or a right click. Obviously, left clicks are going to reveal, and right clicks are going to flag. So if the button's button, I don't know why they do it that way, but button left, else it is button right. So we want to check for left clicks. Well, when you click on a flag, obviously the whole point of the flag is to protect yourself. So we don't want it to do anything in this case. As well as when it's already revealed, we don't want that to do anything because it's already done what it's supposed to do. So we're just going to return true. So that game keeps running. Nothing happens when you click a flagged/revealed tile. Now, on the other hand, that tile is a bomb, meaning it's less than 0, we need to return false because now it is game over. You click the bomb. And finally, if we don't want to do nothing and we don't want to game over, then we need to actually reveal the tile. So there's two different kinds of reveals. There's reveals for numbered tiles that only reveal that tile, but when it's 0, it reveals the whole empty section, so it expands. Obviously, when it just reveals itself, it's easier, so we'll do that first. Just set the state for that tile to revealed, because numbered tiles only reveal themselves, and then return true. So now we need to expand when it's 0. To do this, we're going to be making use of the depth first search algorithm, which is why I love this project so much, is because it's a great way to practice this algorithm, which is very common in leak code questions and interviews and all that jazz. So we're going to create a DFS function, and we're going to pass in our X and Y position as well as the width and height of the grid, and then obviously the grid itself. Then return true because this is a successful reveal. So this is going to be a void function. It's not returning anything. And we are also going to be using recursion here. So I hope I explained this well enough and it's not confusing. So this is the recursive DFS approach. So first off, you always want to have your base case, which is revealing the state. Then we want to do just like how we calculated the neighbor of bombs using the dy and dx function. And then we have some simple conditions that are going to make the loop end. So, or continue, I should say. When dy and dx are 0, that means we're on the current cell. We want to continue because we don't want to recurse down itself because that'll cause Stack Overflow. If it's outside of the bounds of the grid, meaning it's less than or greater than the width or height, we want to continue. If it's a bomb, we obviously don't want to reveal that. If it's already revealed, there's no point in continuing down that path. And finally, we get to the recursive step. If it is a 0 cell at the NYNX position, then we call this DFS function. And pass in the NY and NX. It's not 0, so it's the edge, meaning it has a value. We just reveal it. And so it kind of acts as the border of our DFS, the end of the depth. Let's finish out the function definition. Great algorithm, and this is honestly probably one of my favorite ways to make use of it. All right, let's give this a shot. Bam, full expansion, awesome. So our DFS function is working perfectly. So now we can see where the bombs would be, and now we need to be able to flag them. You can see it's very tiny. It's the same size as our cells, as our tile. So it's 20 by 20. We can create this as an SDL texture, so we can render it in one of the SDL rectangles. After the window and render, let's allocate this texture. So it's called an SDL texture. It's a pointer. And it's going to come from the create texture from surface, which takes in our render, and then we're going to load the surface from this bitmap file called flag.bmp bitmap. In our render function, let's have this take in our texture. To take the texture, and then in our first pass, after we check if it's hidden or flagged, if it's specifically flagged, then render the texture. That takes our render, our texture. We don't need a source rect. We need a destination rec. And then null should be all caps. That's my mistake. Similar to the left click, we want to make sure we don't do anything that we don't want to do. So when a grid tile is already revealed, we want to return true right away, because nothing happens when you flag a revealed tile. If that tile is already flagged, then we want to remove the flag, right? Set it back to hidden. And return true. finally, if those conditions, if it's not revealed and it's not flagged, then just set it to the flag. Outside of our conditional, we can return true, because if it hasn't failed by then everything is good. Let's make and see if everything goes. It compiled. Let's run it. We have our expansion, and let's see grand reveal if we have our flag. Beautiful, we have our flag. Clicking on it is doing nothing, the flag is staying, and we can remove it. Now that we can handle all player input, there's one more small step to this game that's often not thought about, but it makes the ease of playing so much better. So it's what I'm going to refer to as first click safety. So your first click is never a bomb. You don't lose on your first try. We want it to specifically start off on a 0 tile. In addition to the running boolean, I'm going to make another boolean called first click that starts off as true, and it's going to be set to false when it's no longer the first click. So now our input is going to take some more arguments. It's going to take the current mode's bomb count, the array of bombs, and also our first click function, or our first click boolean. Let's modify the function call. Int bomb count, int bombs of size bomb count, and pointer to our first click boolean. Great. Now, after we check if it's already flagged or revealed, and before we game over, we want to check for first click safety. Ensure the first reveal is on a 0 tile that expands. So if first click is true, so we're referencing the value of our first click pointer. If it's true, we're going to run a do while loop. While that specific tile of our first click is not 0, we are going to call our initialize Minesweeper function that we made earlier to refresh our board to something new. After this, we're going to set first click to false. Let's try out the game right now without this change. So obviously I just clicked 1 and it's not a 0, it's a 1. Now let's recompile with our changes. And then click the same one. See, you can see in our terminal here, it regenerated bomb positions. So that means our first click safety is working. Now all that's left to do really is to check when the player can win and let them know. Let's create a function call at the bottom of our game loop called check win conditions. It's going to take our width. I don't need to define those just yet. It's going to take our current mode dot width, current mode height, and our grid, like basically every function here. If check win conditions returns true, that means it is a win. So I'm going to congratulate the player by printing out, congratulations, you win. And then while running, which we know is true, currently we are going to poll until it quits. When quit is requested, we're going to set running to false, so it'll exit the current loop and then also the outer loop. And then finally exit the program. So now let's define this function and call it a video. This is going to return a bool. So we want to make sure that all numbered tiles are revealed. So if the grid tile at XY value is greater than or equal to 0, meaning it's not -1, it's not a bomb, but the Y same tile state is not revealed, we need to return false. If it never finds this condition true and never prints false, then that means you did win. Congratulations. All right, let's see if I can win this thing. Awesome. Okay, I'm not gonna lie, that did take me a few tries, but I finally won. Awesome. Thank you everybody for watching. My code is gonna be up on GitHub, so check the description for that, and I hope you enjoyed. Thank you.